let me record this just in case. Oops. I think we are live.
Cool.
Okay. Wait, let me double check the sound. Hello, everyone, and welcome to today's episode of Quadcast. I am your host, Tim.
And I'm Mikey.
All right, so due to schedule conflict, unfortunately, we don't have Sahil with us, but Mikey is just you and I today, and today's topic is another thought experiment. The title is, what if we can access extra dimension? Yes, the Godonkin experiments.
Yeah.
What if we can access extra dimensions? So in terms of when a physicist looks at that, what exactly does that mean? How do we even think about that?
Well, first, let's talk about what exactly we're saying. So right now, I think we can all agree that we live in three dimensions of space, right? And to most people, you can convince yourself of that by seeing that you can move forwards and backwards, you can move left and right, you can move up and down. And each of those is a dimension of space, and you have the freedom to move in any one of these dimensions. So it seems like our universe has three dimensions of space. And then, of course, as Einstein showed us, you can also think of time as a dimension. So we typically say we live in three dimensions of space plus one of time. So 3 + 1 dimensions. So in a lot of science fiction stuff, like, people often have like fanciful ideas about, maybe higher dimensions, or maybe like if you could access that, what would be the implications of that? And so, yeah, we're going to explore the answers to some of those questions about like how realistic are these scenes, and what would actually be the implications of.
Right. Yeah, but I think before going to the thought experiments more deeply, I think extra dimension itself, it's a reasonable scientific idea. I think Brian Greene and others have popularized the idea that in string theory you actually have what is it, 11 dimensions and whatnot.
Yeah.
So it sounds crazy, but it's actually not that crazy, right? Like because I know I've read plenty of papers about extra dimensions. So how do we think about that?
Yeah. Okay. So first, let's talk about what we mean by extra dimensions. So are you saying, like, okay, let's say instead of being able to move up, down, left, right, and forwards and backwards, there was just some other random direction, and that it was a super long, stretched out dimension. Is that what you're saying? And I can just happen to move there? Um,
Yeah, well, I'm just saying, I'm just in the word extra dimension. It's a little bit loaded, right? It could mean many different things.
yeah.
Yeah.
Mhm,
So I'm sure the audience have heard of like string theory being
mhm.
popularized as having like a lot of extra dimensions, like
Yeah.
11 extra dimensions, whatever. I don't know,
Uh-huh.
5, 6, whatever you call it. Um, but I think this is different from what we're talking about.
Yes. Okay. Actually, here's. I'm glad you mentioned that, because there's actually another like very, very popularized science fiction trope talking about extra dimensions. And those of you who saw Interstellar might remember that they explained it this way: like, imagine our universe is like on a sheet of paper, right? Um, and Interstellar, they say, well, if there's a higher dimension, then you could imagine making a wormhole by like bending the sheet in through the higher dimension, and now these points are close. So, um, Tim, do we want the audience members to have this in their mind when we're talking about higher dimensions?
Yeah, I don't think so. I think that's just way dramatized, right?
Well, no, what they're saying is that you could have a higher dimension, and that you could establish some kind of warping in that higher
Uh-huh.
dimension that would actually like bring. So we're not talking about warpings, or do we want to talk about warpings? Because we might have to talk about warpings.
Right. Yeah, I guess we can have a few different. Actually, there are a few different categories of extra dimensions. I'm glad that you brought it out. I think the ones that string theory proposes are extra. They are extra dimensions, but they're so tiny. So you can't even crawl inside them. So for practical purposes, those cannot be accessed, right?
Mhm.
And then you have the more plausible kind of extra dimensions that are
Hey, wait,
maybe
wait, wait. Not to say that's not plausible. It's perfectly plausible.
right.
I
It's
wouldn't
perfectly plausible, but you don't have
wouldn't
any
say.
evidence for it, right? Yeah. But then you look into some of the extra dimension proposals that people write papers on, that could actually be accessible, maybe not now, but maybe in the near future, maybe in 100 years or whatever, we want to experiment. Those extra dimensions are still not what we see in the science movies. These are
It could
maybe,
be. It could be.
it could be, right? Yeah.
Indiana Jones definitely had warp extra dimensions. That was definitely Randall Sundrum scenario.
Right, but these dimensions would mostly manifest as, they'll show up first as different types of particles, and these dimensions are still quite different from the dimensions that we see. If I were to move into them, it's not like literally I take a step into that extra dimension. But I think that in our thought experiment, we want the most dramatic kind. We're talking about an extra dimension just like up, down, left, right, and front and back that you can just take a step into. Like, which is definitely not what the world is right now. But it's interesting to see what the world would be if that were the case.
Okay, yeah, I think maybe this is a good time to maybe clear up something that's not obvious, which is the fact that so Tim was talking about how there's various different ways you can imagine extra dimensions manifesting. In string theory, there's 6 dimensions that are curled up at the Planck length. So let's just agree we're not talking about Planck length,
Yep.
because those are effectively not part of our reality. Let's
Right.
just assume that. Yeah. Okay. But uh, there are other scenarios, like famously, there's one called large extra dimensions, where you could have a small curled up dimension that has it's actually in the shape of a circle, and the radius could be like on the order of like nanometers now, I guess. Maybe the limit now from the LHC.
No, I think it's
But
quite a bit, probably quite a bit smaller. Maybe smaller than the size of a quark. I think femtometer probably.
okay, yeah, but that's still not that I thought before the LHC the limits were like millimeters though.
I don't know. Yeah, but
That's why they called it large. Yeah, yeah. It was surprisingly large, but so what we have to understand is like let's say that there's an extra dimension, but it's shaped like a circle. Um, as the radius of that circle goes to 0, that dimension effectively disappears. But as the radius of that circle goes to infinity, it essentially becomes a flat extra dimension that you can just move around in freely, right?
yeah,
So
yeah. I
uh,
guess that's interesting. This is not something that people are aware of. Like people think, oh, is the world, does the world have 3 spatial dimensions versus 4 versus 5 spatial dimension? It turns out that it's not all or nothing. There is somewhere in between, kind of. You can kind of have like 3 dimensions and a little bit more, and that
yeah, like three and a
just
half dimensions.
yeah, but maybe not literally, but like depending on how large the extra dimension is,
Yeah.
like the effect of the extra dimension can be either completely removed or
Yeah.
be super apparent.
Mhm.
So I
Yeah.
think, yeah, a lot of sci-fi movies usually explore this realm, like Interstellar. I don't want to be a spoiler. They explore the realm where like this extra dimension is fully accessible. Like you can more or less just kind of explore it in some crazy way.
Yeah. hmm and it sounds kind of abstract, but it's really not. Okay. Like imagine that if I went in one direction, like in space, imagine that uh space was such that I go like infinitely far in one direction and then I end up back in the same place. Right. That's what happens when you walk around the Earth, right? If you walk in one direction, you're going to end up back in the same place. You could imagine that one direction of the universe could also behave like that. Like if I move in one direction, I'll end up back in the same place. That would be some indication that that dimension is circularly shaped. Now, if I take the radius of that circle to 0, what does that mean? It just means that like whenever I move in that direction, I'm constantly going back to the same place again, and I wouldn't even notice that that dimension exists unless I checked like very, 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 very small timescales and distances. Um, so we're specifically also not talking about that.
Yeah, yeah, yeah. So I think in conclusion, like extra dimension is a very plausible hypothesis if they are very small, right?
Hmm.
But so I think let's go into the thought experiment now.
No, 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 no. There's one more. There's one more. There's warped, right? So the other way that extra dimensions could happen is maybe not, they're not small. Maybe there is another dimension that's big and we could access it, but maybe there's effectively some force that's keeping us stuck.
Right, some
But
bottleneck.
yeah,
Yeah,
we can't really get access it just because we don't have like enough energy to. Um, and that one is probably the closest to what we're talking about, right? This goes by the name of warped extra dimensions,
yeah,
right?
yeah. But
There's-
although in physics, it always turns out that the two viewpoints are actually there's a duality between them.
yes.
Uh, because of quantum physics, one way like a warp extra dimension can be very similar to being stuck on a particular dimension, like being stuck on a sheet of paper, sort of. Um, but let's not get into that, right?
Okay.
So there's a lot of nuanced
Yeah.
discussion on extra
Well,
dimension. I think.
I think for the purposes of my own sanity in this discussion, like that's my reference point because that's the closest thing I can think of to, I could just think of a warp. I can just think of a Randall-Sundrum warp scenario where the warping goes to
Yeah.
0, and that'll tell me
Right.
what's gonna happen.
Yeah. So there are many ways to view it. And yeah, and those are in technical papers, technical publications that people explore all kinds of possibility. But
Yeah.
okay,
Yeah.
but let's get back to it. So
Okay.
what people
Yeah.
don't what people don't
No.
really explore is this crazy possibility. Like, what if there's just literally a very large, very accessible extra dimension that I can up, down, left, right, front, back, and I don't know, the extra dimension I can just step into.
Well,
What
let's be
would that?
fair. It's not that people haven't explored it. Certainly, people have thought about it. It's just that like you run into immediate problems, so they don't go further. But let's go further.
Right, right, right. So what? Yeah. So what's the first thing that would change
Yeah,
if
okay.
we?
Yeah, I kind of want to know what like if you imagine just opening up another dimension, like now, yeah, instead of 3+1 dimensions of space-time, we have 4+1, and those four are just big open. So I don't know. A lot of people might have heard of the term tesseract. This is a cube in 4 dimensions. There's some cool apps you can download where you can play with it. But essentially, we're living in a reality now where these tesseracts are like the main building blocks as opposed to like cubes, right? So Tim, like, what's the first thing that strikes you would be like drastically different in this world of tesseracts?
Yeah, I think mathematically the first thing is that the concepts of surfaces and volumes immediately be different. You know,
Yeah,
like in a larger dimension, the volumes increase, the surface
yeah,
area also increase, and
yeah.
the physical consequences is that the effects of forces will get more diluted.
Wait, let's
Basically,
be more specific. It's not that it just increases, is that it increases more drastically than you can imagine.
yeah, yeah,
Uh,
yeah,
like
yeah.
in machine learning, data science, people have often call this the curse of dimensionality. Like
Mhm.
where when you just every single new direction, it doesn't just increase the complexity linearly, it increases it exponentially. And you're often dead in the water when you just go up one dimension in terms of the
Yeah,
complexity that can happen.
yeah. I think there's a good analogy. It's like imagining imagine you grab like a garden hose and you're just spraying water all over the lawn, right? The amount of water that you get, how much you get wet, as a function of how far you are away from the garden hose with water spraying all over the place, goes like 1/r square in our world. Yeah. And coincidentally, well, not coincidentally, this is exactly how forces, the strength of forces change, like electromagnetism and gravity. That's how the forces will change as a function of distance. It goes like 1 over the distance square. And if you have more dimension, this garden hose of forces and border and forces, it will actually go like 1 over r to the cube. And as a result, the forces will drastically different. It means that for the same distance, you know, like the force I feel, like for example, imagine I'm on Earth, you know, the gravity I feel from the Earth will be a lot lower than what you would expect it if it was in a lower dimension, right?
Well, depending on how close you are.
Right, depends how close you are. And yeah, and on the contrary, right? Like if you are closer to the center of the Earth, this increase in gravity will be a lot stronger as well. All of a
Okay,
sudden,
well,
be
let's be
like,
clear. Let's be clear. Well, the garden hose situation, I would not get nearly as wet.
basically,
As long as I was far enough away, like, yeah, just get like a few drops on me. So, and if I was putting a magnet on a refrigerator, everyone knows that if you put a magnet next to a refrigerator, the attraction is very strong when you're close, but then when it's far away,
yeah,
the attraction basically goes to zero. So in this case, the magnet would be like insanely stronger when it's close, but then it would get weaker like very, very quickly, like almost instantly. So the turn on would be like super sharp.
yeah. Basically, the weak gets weaker and the strong gets stronger. It's
Yeah.
like I don't know, economy or something.
Yeah, it's a definitely positive feedback.
So yeah, so I think in hydrogen physics, it is well known that if you have extra dimension, the forces become much stronger at shorter distance and becomes much weaker at a larger distance.
Yeah.
And this will totally screw up the hierarchy of the different forces. And this is probably the number one effect. The entire universe will experience the relative strength of different forces way differently.
Yeah.
So
Okay.
for
That
the
kind of
most
brings me to the
part,
next question, actually. So, like, yeah. So you're saying that, like, distances far away would be much weaker, and at distances very close would be much stronger. So, could you have galaxies? Could you have clusters? Could you have stellar nurseries? Could you have like a high production of stars in this universe?
that's not an easy question to answer,
No, it's
honestly.
not.
Because imagine this: planets
Yeah.
right now it's a sphere, right? Like it's a ball, okay, a ball, but
Yeah.
or a sphere. If we had a higher dimension, planets will be a hypersphere now.
Uh-huh.
So I'm more inclined to say that probably there will be fewer structures like galaxies and whatnot, because in order for things to clump together, because the volume is so large in
Yeah.
high dimension, you need more stuff to clump, and it's gonna get harder, particularly when
Yeah.
things are far away. They feel less attraction. So I feel like it's harder to clump, but maybe it's still clumpable. What do you
Okay.
think?
Okay. Well, so I guess most of the clumpiness that we have now comes from the dark matter, right? So you
It's
could
true.
say maybe if the dark matter was like, hey, actually, this is something we actually haven't talked about yet. Is it possible that like if you had like if you had an inflation scenario, right? And reheating, which is, for those that don't know, that there was a period of the universe where it stopped expanding and the friction from that caused all of the matter particles to be created.
Yeah.
Um, that was happening in 4D. Would there be like a greater density of
Oh yeah, possibly, because there's more volume for your
yeah.
inflating field, and so
Yeah.
so yeah, so maybe you will be compensated by higher and higher energy. But then once again, the forces has a steeper on ramp, right?
Yeah.
And as a result, all forces will be stronger, well, compared to gravity. So all the forces will likely be quite a bit stronger. And if we
What
have
would
so
the
much,
CMB look like, huh?
sorry,
What would the CMB look like, huh?
I
It would be
I'm I don't know. I don't know if if we'll even get to that. If we have so much energy and matter, you might just form black holes. Like in fact,
Not everywhere. Yeah, there might
but
be a
there'll be
lot of black.
more.
I'm
So
sure that I'm sure that depends on the tuning of like,
yeah,
like when like the steepness of the potentials and stuff like that.
yeah. I think we talk about. I don't know if we want to get into that, but in high dimensions, you can have higher dimensional black holes. Like you can have black strings, black
Yeah.
like defects in the space time that are black hole like.
Yeah.
With event horizons that are not just a sphere but like extended
Yeah.
structure. Man, the universe might be crazy. Might be crazy.
I mean, that could be our universe. It could just be that we can't see the string part of the black holes because we're stuck on one side of the brain.
Maybe God. Yeah. So I would say we don't know. I don't think anyone has ever done. Maybe someone has done the calculation, but probably not in detail. But
That would be
I would say
fun.
maybe
Good. How's that crazy?
maybe. I think you cannot rule out that structures can form. Maybe galaxies wouldn't be like a
Yeah.
disk. It would be like a
Uh-huh.
hyper disk with some crazy shape. I don't even know what that would be like.
Okay,
But
well, okay, like, you could definitely say that if the dark matter to visible matter ratios were the same as they are now, and the energy density was the same, then probably maybe large scale structure would not be possible. But like if I tune the density of dark matter up, times 1,000, then I think it's clear to say that there is definitely possibility of large scale structure in such a
yeah,
universe.
yeah. Like if God was to make a four-dimensional space, 4+1 dimensional space time with structure, I think it can be done. It
Yeah,
feels like it
yeah.
can be done. So let's just say,
Probably tune up the dark matter, probably increase some kind of friction ratio from reheating.
yeah, the forces of the strong force, electromagnetic force, and gravity will have to be dialed just
Yeah.
right so that they're not like too crazy. So
Well,
okay.
yeah. It's not like our universe isn't fine-tuned, so
So yeah, so let's just say it's possible, but the galaxies
okay.
will be way super weird. These
Yeah,
are
yeah,
higher
yeah.
dimensional galaxies.
They'll be way more they'll probably be like, as far as the varieties we see in terms of now like disk galaxies or like
Bars and
there's
yeah,
all these things. It'll
cigars.
be way crazier. The taxonomy of galaxies will be like wild.
Probably.
Awesome. You probably have like string galaxies and
But
following
string black holes, like yeah, because at the center of every galaxy there's a supermassive black hole. Maybe you
yeah,
get like string, like I don't know, some crazy stringy
yeah,
looking galaxy with stringy looking black holes in the middle. Like a tornado, like galaxy tornado. This is,
yeah.
by the way, this is purely speculative. No one has ever done calculations
Oh
of this
no, but we,
sort.
we, we can kind of imagine imagine that what we see is a three-dimensional projection, and you can that allows you to
Yeah.
extrapolate in some way what these objects could look
Yeah,
like, right?
I think it's fair that there could be more variety because with extra dimensions, there are extra ways things can be.
Yeah.
Right. Okay.
The complexity and variety of everything, I think, would uniformly go up across the board.
Right. Okay. So
Yeah.
what's next? Right. So
Okay.
now we have universe and galaxy.
Yeah, okay. We didn't cover, but I think it's fair to say that a large universe is possible. Given the fine amount of fine tuning that we have in our universe, we can have a large universe with complex structures that can give birth to, um, you know, subgalactic structures. Okay. So I think the next on the list is once you have these subgalactic structures, which in our universe look like solar systems, but in this universe could be something different, but there's some substructure in there. And then once you have that kind of substructure and some kind of way of uh, creating endothermic processes, exothermic processes like stars. And next question is, can you have chemistry?
Yeah. So that's tough. I mean, I don't even know how to answer that. So first of all, chemistry is supported by quantum physics. I'm sure
Yes.
people learn chemistry. There are these
Yeah,
orbitals,
quantum physics
electron.
in 5 dimensions.
Yep. So I don't know what these orbitals are going to be like. You can fit a lot more electrons for sure. There's a chance they won't exist, but let's say they still exist. But that you get way more orbitals. Is it fair to say that chemistry could go crazy? Like you could
Well,
have.
okay, well, why don't we start simple? Can you have hydrogen?
I feel like you can, assuming protons exist. Okay,
Okay, yeah,
like assuming.
assuming that yeah, okay. Assuming that the whatever gauge groups exist in this universe, assuming that they can give rise to combinations of neutral oppositely charged fermions with a mass hierarchy. That I would call that a hydrogen atom, right? Okay.
Yeah, yeah. For those who are unfamiliar, like in order to have a hydrogen atom, you have to have a proton and an electron, and a proton has to be formed by the strong force. And in order for the electron to bind to the proton, it needs electromagnetism, right? So if the universe is has an extra dimension, all this will be drastically different. But we're questioning and see if something analogous can exist, and it feels like, yeah, I guess.
Hold on, wait. Let this. Okay, can I just take some time to make this a bit more precise?
Yeah,
Okay. Let's like I'm going to kick this can down the road, but what we have to assume here is that okay, that this universe allows us to have a hierarchy in forces as we observe in our universe. Let's say that's a given, because I think that's a
yeah, yeah.
given.
Well, let me clarify, right? Like the strong forces has better be a lot stronger than the electromagnetic forces. Otherwise,
Oh, I was talking
every
about the gravity hierarchy. The
right,
gravity
yeah,
hierarchy, like as much as that's fine-tuned in our universe, we can say that's fine-tuned in this universe. Okay, so
yeah,
there's a
yeah,
gravity
yeah.
hierarchy,
That's a given, yeah.
and there's some kind of a flavor hierarchy. So we have particles of different masses, and so we end
Right.
up with a positive guy and a negative guy. And can they become bound together? That's the question.
Yeah. I feel like the answer must be yes. If you solve the same equation, Schrodinger's
Yeah.
equation, you should. I mean, you have an extra dimension, yeah, but the equation should give you some sort of bound state. But because of the high dimensional nature, the forces get a lot weaker as you go further out. I
Huh.
think the bound state will become a little more tenuous. They're a little
Oh.
more easily disruptible, but there certainly are bound states. I think
So
they're
chemistry, you predict chemistry will be more volatile?
I think chemistry will have to involve more energy. Like even though we say that there's a hierarchy between strong forces and electromagnetism, like there's a clear difference in our world right now. Whether you do a little chemistry experiment versus detonating a nuclear bomb, right? Nuclear bomb is when strong forces are involved. When you do
Yeah.
chemistry, you I don't know, you ignite hydrogen. Just a boom in a balloon, right? And
Wow.
not quite a nuclear reaction. But in the extra dimensional world that distinction must be a little less, no matter how much you tune it. Because in
Uh-huh.
order for atoms to bond, the electron, the electron equivalent, will have to be a lot closer, and it would just be that much tighter,
Uh-huh.
right? And it requires to like the amount of force, because if it's far away, the force would just be too weak. So
Yeah.
in a sense, you kind of need more energy to bind them, and it's also more tenuous, if that makes sense.
I mean, well, if you think about like the escape energy, what it takes to kick an electron out, it would just change that spectrum, right?
I guess it will, yeah. So chemistry will be way different.
But I think I mean, as insofar as an atom is just a particle in a box, I think it would be roughly the same
Eh,
in terms of
I would
bonding.
put money on it that it should exist.
Yeah. But yeah, but okay, so going back to what you said before about like the orbital shapes, man, well, what do spherical harmonics look like in 4 dimensions? The kinds of geometries you could have for complex molecules would probably be like, even if, let's say it's true somehow that like these molecular bonds are somehow less stable, the sheer variety of configurations you could have must make up for that in some way.
Yeah, possibly. Yeah, because right now, what for carbon? Carbon only has like a carbon has four bonds, so it
Yeah.
can only rearrange itself in so many ways in 3D.
Yeah, I mean, yeah, the dumbbell shapes, right? The PD
The
orbitals
yeah, the
determine the volume. Yeah,
tetrahedrons, whatever, for
yeah.
carbon, right?
Oh my God,
But
you turn that into a tesseract, and then the number of like, imagine protein folding. Proteins could fold in the most
what
insane
if we
way.
make? Yeah, the chemistry will be man, like maybe the number of elements will drastically reduce, but
Yeah,
then the variety of chemistry, the variety of bonding structure will go crazy. You have
yeah,
like yeah, like molecular tesseract.
yeah,
Is that even a word?
yeah,
That would be kind of wild, I guess. But then maybe it would be too wild for to be consistent, right? Like 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 if we take a hydrogen molecule, we know it's always a single bond. But and for more complex structure, let's say methane, right? It's
sure.
always like a carbon hydrogen bond. But if I can imagine in higher dimension, wouldn't it be like a lot more wobbly? Like the bonds are kind of maybe not. I guess there's some
No, no, there would always be a potential minimum that what they would settle to, right? And that landscape could be way more complicated, but
yeah,
and
yeah,
it
yeah.
could be more sensitive to fluctuations, but uh, yeah, if anything, that would just mean that like it it would be more likely to survive in the cold vacuum of space.
Yeah, so okay, so I think I would buy that something like somewhat complicated molecules can exist. There's also one fact we didn't mention. Like in order for life on Earth to exist, we do need like very high atomic number, like trace metals, like iron, like lead, and all these.
Sure.
But and then those depend on like those
Wait,
come
why do
from
we need those? Why do we need those?
well, I don't know if we absolutely need it, but like like our stars have high metallicity. They have like these trace metals, and I presumably life requires trace at least utilizes trace minerals to thrive, and it's not clear if life could exist without them. But
Yeah. Hmm.
but then if you focus on those facts, like complex the existence of these high atomic number elements come from supernova, and the way supernova deposit these material is that they explode and then they spread out, and like we said
Yeah.
before, they spread out. Just it's like a garden hose when you grab garden hose and you water things everywhere. Now that will reduce dramatically, but maybe it's still okay, like trace
Yeah.
minerals. But if we can get that far, I guess it's safe to say that these rare earth minerals, if they exist in this extra dimensional world, will be even
Yeah.
rarer. I don't know.
Yeah.
Gold will be even rarer if such a thing exists.
Oh, okay. No, we've already made drastic simplificative assumptions about just the fact that there is a hierarchy and just the fact that there can be long range U1 forces. Let's
Yeah, electromagnetism.
Oh, hey, sorry. Here,
Yeah,
there's another fact.
yeah, yeah. So it is. Hmm.
We can cut that out. Okay. Um, so where were we?
Yeah, so I think we were saying that complicated chemistry could perhaps exist. Maybe the
Yes.
variety of elements might be reduced. Maybe the energy that are involved in these chemical reactions might have to increase, and the variety will be drastically different.
Yes,
Um,
drastically increased, which I think that would make up for. I think the answer is yes. Whether it would be enough to support the kinds of organic chemistry that we know
yeah,
is an open question, but I would say there's certainly enough room to entertain the possibility.
yeah. So I guess the next obvious question is, could there be life, right? And how would life be different in this
Wait, no, no,
universe?
no, no. Okay, that's hard. I feel like we should go the other way. The question is like we're keep going down this road. Okay, so could we have particle physics that allows structures to grow?
What do you mean? Just like cosmological structure, or just like complex structures?
Well, could we have a proton?
Yeah. Well, I mean,
I don't think you could have a proton.
I thought we already assumed that in order to have chemistry, you have to have
I
a
know
proton.
we assume that, but now we assume that just like because we're going down in scale, and
Yeah.
now we have to face this assumption: can we have a proton? I don't know. I don't know if we can have a pro. I don't think we can have protons.
Uh, yeah. So protons rely on the strong force, which is very, very, very strong, and it's so
Yeah.
strong that it's what people call non-perturbative. Um, but I feel like you could because like having extra dimensions are known to cause very strong forces. In fact, I think something like a proton is more likely than something like an atom in this extra dimensional world because
Uh,
things tend to clump more because the forces are stronger the closer you are.
sure.
This sharper ramp up will actually favor strongly binding stuff like the proton. Like proton, you can argue it's a strongly binding non-perturbative
Sure.
object, which is
Yeah, yeah,
kind of
yeah. Oh,
what
you could definitely have. Yes, you could definitely have protons in that sense. Could you have a Higgs boson?
uh you certainly could, but one of the features of the Higgs boson is that its interactions are relatively weak, and
Mhm.
that's what it means to have a Higgs boson. We don't quite know what it means when the Higgs boson has very, very strong interaction, which is what high dimension tend to give you. Because remember, this higher on ramp, the closer you are, the stronger things are, and that's why when
Yeah.
you zoom in to subatomic level, in with an extra dimension, forces will just ramp up. Everything all of a sudden is very, very strong, and that includes all the forces and also gravity. So like the Higgs boson, yeah, but it's gonna be I think no one knows. Like like non-perturbative five-dimensional particle physics.
Uh-huh.
You just can't calculate anything like that. Yeah,
Yeah. Hmm.
but I think you can't rule that out. And that's what it is. You cannot rule that out. I'm sure, like if God wants to make it work, if God exists,
Hmm.
uh, he God can make it work.
Can you have chiral fermions in?
Oh yeah, so that's something. So I think we have to explain to the audience what the hell chiral fermion
Yeah, yeah, yeah,
is in the first place.
yeah.
So yeah, so chiral fermion is to put it loosely, it's a feature pretty unique to four dimension like three-dimensional space plus 3 plus 1 dimensional world. It is responsible to the fact that neutrinos have almost no mass, mostly, um, and also responsible for the fact that a
It's the
lot
reason why
elect
everything has almost no mass.
yeah, yeah. That's the reason why electrons don't make black holes. In 5 dimension, this feature disappears. What you get is that yeah, I think this is more abstract now. So far we've been discussing how forces will get modified if you have an extra dimension, but also matter gets modified if you have an extra dimension because matter has to have different ways of moving basically, and this as a result creates more types of matter. That makes sense. So like matter particles have to have more components. So in 4 dimension, in 3 plus 1 dimension, uh in some sense you can have particle anti-particle. In 5 dimensions, you almost have to double that for some of the particles, right? You have to like have more. Um so what you say about chiral fermions, yeah, definitely goes out the window. You cannot have that.
Yeah. Well, okay. Yeah. Is there a simpler way to just reiterate that? Like, so right, every particle has an antiparticle, right? And okay, now I'm going to start to say wrong things because, um, but it's going to be right in sphere, right? And you can roughly think of a particle antiparticle as kind of being like two distinct particles that are sort of like paired up together,
Mm,
right? The left-handed and the right-handed component. Um, because we live in 3 plus 1 dimensions, it's possible for one, instead of having them coupled up, it's possible for one to just exist by its lonesome.
yeah.
Uh, I think in four, if there's four spatial dimensions, it's not possible to have a particle just by its lonesome. It has to have um it has to have a partner particle. So every single particle and antiparticle would be matched, so to speak. And there, a lot of things about our universe are resting on the fact that in our universe, we have particles that are not matched with a partner,
Yeah.
which allows them to talk to the Higgs, which allows them to be light and
Yeah,
serve
so
us.
yeah, so that feature will be gone. I wonder if that'll impact our matter antimatter asymmetry, right? Because in order for our
Well, it depends on
universe,
your theory of depends on your theory of how matter antimatter symmetry is created.
yeah, because in order for our
A
universe to
very model dependent
yeah,
question.
because in order for our universe to exist, right, like we have more matter than antimatter. But
Yeah.
if the theory forces the matter and antimatter to always come in pairs,
Yeah.
maybe that will jeopardize some of
Certainly, it
that.
would certainly 99% of theories of matter antimatter asymmetry would be ruled out. Certainly.
Yeah, I mean,
They all rely in some way on the fact that they're allowed to like disconnect these pairs in three dimensions.
yeah, I mean, we might be saying wrong things. This is getting highly technical now. Like, it could be it could be that this is immediately no go for our universe, right? Like, you have nothing left. Matter, antimatter, all annihilate, and there's no way to
Really?
have leftover.
Are you telling me that there's no theory for matter antimatter asymmetry that involves like completely vector-like fermions? There's
No,
gotta be
I'm not saying that. I'm not saying that.
gotta be somehow. There's gotta be
It's
somehow.
probably a lot. Yeah, a bit harder. But I mean, I think on the basis that we cannot rule it out,
Yeah.
then we have to assume that maybe it's plausible. Like
Okay.
if God is there, he or she
Yeah.
will be able to make it to work. Let's say.
Okay. So as long as we allow for the presence of extreme fine-tuning that allows vector-like fermions to be light, just because of some
Yeah.
anthropic, then we're good.
Yeah. Okay. So I know we're running out of time a little bit
Yeah.
here. Maybe for the last question, let's suspend our belief
Hmm.
and say that life can somehow exist
Yeah.
despite all that.
Uh-huh.
What would be the pros and cons of living in this universe that you can think of?
I think I'd be a lot smarter.
Right,
Like
because
I would definitely beat the hell out of like a three-dimensional being in an IQ test just because my spatial awareness and yeah, just spatial awareness intelligence would be
oh yeah,
just
is it fair to say that your neural wirings, because of the extra dimension, you can have more connections and you'll be able to think? Yeah, you'll be able to think in a higher dimension, so that
yeah,
might open up its possibilities.
yeah.
Well, there's some curious facts, right? Like for example, I think in a society like there'll be no housing crisis because the volume, the surface area of the Earth will be a lot larger.
Space becomes very cheap.
Yeah, space becomes very cheap, but
Yeah,
at a cost, communication becomes a lot harder
yeah,
because of the 1/r cube. Like
yeah.
the signals, imagine your radio tower, the amount of signal that you receive when you're far away will go down will go a lot quicker. So
Well, no, that would just make fiber optic cables like a much more like useful commodity. The amount of gain you'd get from a fiber optic cable would be much greater than it is in our
sure, I
world.
guess so. Right, I guess if you have a broadcasting station, you have like beams. You'll be beaming signals left
Yeah.
and right as opposed to spreading them out.
It just means that networking becomes a far more efficient form of communication than broadcasting.
I think that's fair. That's
Yeah,
fair. That's fair.
yeah.
And
So
also another curious fact is that you cannot tie knots because every knot can be undone in 4 dimensions. So unfortunately, I think is it fair to say rock climbing is a no go or maybe?
um, wait, hold on. I don't understand. I don't know that much about knot theory. Is it like every three-dimensional knot can be untied in four dimensions, or like can you can't make a four-dimensional knot that can be untied?
I think the theorem is like every,
Something
but I could be
special?
totally wrong. Um, I think every you can always trivially embed something in two times n plus one or something like
Oh,
that. So one dimension one times someone plus Well,
Is it like
well,
even dimensions can't be knotted?
every one-dimensional thing can be embedded in 3 dimension.
Yeah.
But I forgot. I could be totally wrong, but I'm pretty sure that the knots can be undone trivially.
Uh,
In if you have an extra dimension, it just ways to you can just cross one rope over the other in the extra dimension.
yeah. But then I would think maybe, well, why can't I tie a four-dimensional knot? They can be untied in any five dimensions, but not.
I guess you can tie knots using different like what is a string now? Is it high dimension? I don't know. I don't. It's hard to think about. I'm sure you'll find other ways to entertain yourselves, like with the extra dimension. So yeah. Okay, looks like we have some connection issue. Um, well, anyway, I'm gonna try to address this audience questions. Could we be living in an infinite dimensional universe, but with the effective number of dimensions being 3, similar to how electrons effectively live on a plane? Um, well, I don't know about infinite dimensional universe. Certainly, electrons are living in the 3 plus 1 dimensional universe, and they're just stuck in a material because of the electromagnetic forces trapping them there. So the analogy isn't there. It will be hard to imagine something outside of the universe that the universe is in. But there are certainly theories where you could have an extra dimension, but then our visible universe is stuck, like a sheet of paper, stuck on a high dimensional world. So these are what we call brain world scenario that we described earlier. And also, like we mentioned before, the physics is very similar to if the dimensions was warped, or the extra dimensions are wrapped in a very small circle. So this is certainly a plausibility, but not infinite dimensional. Like we could be in a 10-dimensional world, but then our 4-dimensional world is just a sheet, like a thin sheet, if you can imagine it, in this high-dimensional world, and it just takes so much energy to reach out that we're not able to do it yet. Okay, so it looks like unfortunately Mikey is having some internet issue, and given our time constraint, and I will just hello, we got you
yeah.
back. I thought you got
Yeah.
disconnected, but anyway, I was about to just wrap up.
Okay. Yeah. So, final question: would you want to live in this universe?
Oh, that's a tough call. I think as a physicist, I would love to give it a shot.
Yeah, me too. Yeah.
I
That
thought
was
about
not
it.
hard for me.
It might be terrible to live there. The world might be very inconvenient, but hey, at least we can afford a house, maybe, or everyone can afford a house. And gravity, the differential between different forces will be much closer. That as a physicist, that would be a amazing playground.
Yeah. And I think in general, you would just be able to outsmart every single three-dimensional being that you
No,
encounter.
but then you'll be contemplating like 6 dimensional beings. You'll just be a moving goalpost. You just be like, oh, I wonder, what if it was even higher?
No, I think at a certain point it would just become too much for me.
You think it's enough?
I would just like a little bit of a boost. I don't want
Maybe wait until 11 dimensional so you can see if string theory is real. Maybe that's.
I feel like four spatial dimensions is it still has a little bit of intuition, and if I go beyond that, and then I lose all
Yeah.
intuition, and then I'm just like floating in a sea of confusion. But
Right. Yeah. I think I would say that 5 dimension is closer to 6 dimension compared to when you compare 4 to 5. The
yeah,
difference between 5 and 6 is smaller than the difference between 4 and 5, and
yeah,
therefore,
five and six are basically the same.
kind of course. But anyway, you know,
Totally.
due to time constraint, I want to thank everyone for joining us, and
Yeah.
hopefully, we'll see you all next time.